Okay, so this is going to be our last set over reactions. So the last type of reactions we're going to talk about are acid-base reactions and combustion reactions. So an acid-base reaction is also known as a neutralization reaction. The products of a neutralization reaction are always a salt and water. Okay, so from our study of acids before this, we know that an acid starts with an H and a base ends with an OH. That's called the Arrhenius acid and Arrhenius base definition. Okay, so these problems work exactly like double replacement, but we're not going to use our solubility rules on them because it's always going to form a salt and water. And we know that there's going to be a product form because the water is going to be liquid. Okay, so there's no need to really do that. So same approach, we're going to take these two ions and put them together. Potassium has a +1 charge. Here, I'm going to write it down here. Go ahead and rewrite it down here. So KOH plus H2SO4. So we're going to take the outer two ions and put them together. Like that. So potassium has a +1 charge. SO4 has a -2 charge. So we crisscross. Now, when we put an H and an OH together, we get water. So we just write H2O. That. Now, if you want to balance it easier, you can write it as HOH. That's perfectly fine with me. Either way is acceptable. So we'll go to balance this. We have 2 Ks on this side, so we need to put 2 Ks on this side. 2 OHs, put 2 OHs. 2 H's, 2 H's, 1 SO4, 1 SO4, and it's balanced. Okay, the next one, calcium hydroxide. So calcium Ca with a +2 charge. Hydroxide is OH with a -1 charge. We crisscross, we get that. Nitric acid is HNO3. Acids always start with hydrogen. Nitric goes with nitrate. So they're equal and opposite charges, so we don't crisscross. Now, what we're going to do is we're going to take the outer two ions and put them together, just like that. Calcium has a +2 charge. NO3 has a -1 charge. We crisscross. We keep the polyatomic ion together using parentheses. Okay? And then when I take an H and an OH and put it together, you get water, or HOH. Okay? If you want to leave it like that, that's fine with me. Now we go to balance this. 2 nitrates on this side, I need 2 nitrates on this side. 2 hydrogens, 2 hydrogens. 2 OHs, 2 OHs, 1 calcium, 1 calcium, and it's balanced. Now the next type of reaction is called a combustion reaction. So combustion is a fancy word for burning, okay? Combustion reaction always produces carbon dioxide and water. So these are super easy to do. The hardest part about this is actually balancing it. So we're going to take C3H8 propane plus O2. Your products are always carbon dioxide and water. Now, when we balance a combustion reaction, we always balance the carbons first. So we put 3 carbons here, 3 carbons there. Balance your hydrogens next. You have 8 on this side, so I have to multiply this by 4. Now we're going to count our oxygens last. So 3 times 2 is 6, plus 4 is 10 total. So 10 divided by 2 gives you a 5 right here. And it's balanced. Okay, the next one, butane. So we've got C4H10 plus O2. Always produces CO2 and water. Okay, so we're going to balance our carbons first. 4 carbons on this side, we put 4 carbons on that side. Hydrogens, you got 10 on this side, so we put a 5 right here. Now we're going to go through and count our oxygens last. 4 times 2 is 8, plus 5 is 13 total. So anytime you get an odd number, so we got 13 on the side, you have to put 13 halves in front because 13 halves times 2 gives you 13 total. Now, we can't have fractions whenever we balance the equation, so we're going to double everything to get rid of the fraction. Like that. Okay, and then our last example problem. C10H22 plus oxygen always produces CO2 and water. So we're going to balance our carbons first. So we've got 10 carbons on this side. I need to put 10 carbons on that side. 22 hydrogens on this side. 22 hydrogens on this side. Now I'm going to count my my oxygens last. So 10 times 2 is 20, plus 11 is 31. It's an odd number, so we have to multiply by 31 halves. Now, we got to get rid of that fraction, so we double everything to get rid of the fraction. Now, I know most of you probably had questions on these on the balancing homework, how to balance the combustion ones. So your steps are always balance the carbon first, the hydrogen second, and go through and count your oxygens last. Now, whenever you count your oxygens, if they're odd, you have to make sure that you do the fraction thing, okay? And just one last little note. A hydrocarbon is anything that contains hydrogen and carbon in it. So just keep that in mind whenever we're doing that. So the substance is actually in the name. It has carbon and hydrogen. I won't make you write these from words because you don't know what this stuff is. You don't know what propane is. You don't know what butane is yet. You'll learn that on your next exam. Okay, so hopefully this helped you out, and thanks. Have a good night.